Now for a simple model like this, there's not a great advantage of using the matrix algebra approach. But I want to show you, using a simple model, how you would write it in matrix algebra format. Because if you had 10 equations and 10 unknowns, you would definitely want to write it in a matrix algebra format. You would not want to try to solve that by hand. Okay. Now, there are three components of a linear equation system. There's the coefficient matrix, A. There is X, which is a vector of variables. And finally, there's a right-hand side vector of constants. And let me just use RHS for right-hand side. Constants or parameters. Or possibly, Brittany, what you said earlier, they could be exogenous variables too. Okay. Now, in this case, right here, the general case, the coefficient matrix A is just this. A matrix is by definition just a rectangular array of constants or parameters or possibly variables. But it's a rectangular array. And a matrix has a certain number of rows and a certain number of columns. And the number of rows and the number of columns comprise the dimension of the matrix. So for this case right here, the coefficient matrix would just be this. For that equation system, the coefficient matrix is just A11, A12, A13, dot, 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 A1n for your first row. And then A21, A22, A23, dot, 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 A2n. And then the last row of the coefficient matrix would be AM1, AM2, AM3, dot, 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 AMN. Okay. This matrix right here has m rows and n columns. So it has dimension m by n. This first number refers to the number of rows. Then you put an x, and then this next number refers to the number of columns. Okay, m rows and n columns. This m by n is the dimension of the matrix. Okay. X without any subscript. Notice this x here doesn't have a subscript. We'll just let that denote the vector. Okay. So x is just this. It is just a list of the variables in a column. When a matrix has just one column, or when a matrix has just one row, it's said to be a vector, V-E-C-T-O-R. So this is said to be a column vector. And what is the dimension of this column vector? What's its dimension? N. Turn it around. How many rows are there? How many rows?
N by 1.
Yeah. There are n rows in just one column. So this has a dimension n by 1. Vectors are just special types of matrices. They either have just one column or one row. So this is a column vector. Okay. And the final component of this equation system is the d vector. And it is the vector of right-hand side constants. d1, d2, d3, dot, 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 d sub m. And it has a dimension of what? What's its dimension? M by 1. Notice it has m rows and just one column. Now, I will show you a little bit later today how you could rewrite this equation system more simply using matrix algebra as AX equals D. Writing this equation system, this linear equation system this way, takes up less chalk, takes up less space, and it also allows us to think about the equation system with our limited abilities. The mind has limitations, and it's easier to grasp and understand a few symbols like that, AX equals D, than it is to understand this set of equations written this way. So this more compact notation is very useful. And later on, we will show how we can develop a systematic way of solving these linear equation systems for the variables, for the equilibrium values of the variables. Okay. But first, we need to learn how to write it in matrix algebra form. Okay. This term here, to repeat, this capital A is the coefficient matrix. This X is the vector of variables. And let me emphasize, it's what kind of vector? What kind of vector is X? A column vector. And D is the column vector of right-hand side constants. Okay, I'll just say constants. Could be vectors or exogenous variables too. Okay. All right. Okay, that's where we're headed. You're going to learn how to write equation systems in matrix algebra form, and eventually you're going to learn how to solve them using the tools of matrix algebra.